Hi everyone, welcome to another mathematics class with Zara. Today we'll continue with the laws of indices. The third law is bracket with indices. If you are given this expression, the third law states that you multiply the power by themselves to give us a raised to the power of x by y. To give us a raised to the power of x times y, xy. Let's say a raised to the power of 3, all in brackets raised to the power of 4. In this instance, the law automatically tells us that we are multiplying the powers. A raised to the power 3 times 4, which is a raised to the power 12. Now, let's prove this. If you have a raised to the power of 3, it's just like saying a in 3 places like we've known before. A in 3 places raised to the power of 4. This is the same thing as this. So now looking at this, all of this raised to the power of 4 is just like saying a times a times a, 1, a times a times a, 2, a times a times a, 3, a times a times a, 4. So this is like saying a times a times a in 4 places to give us what? A times 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 a. So now we have succeeded in removing the brackets to give us a raised to the power of how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to give us a raised to the power of 12. So this is the same as this. Applying the law, this is faster. Let's look at other examples. Y raised to the power 4, all in bracket of 5. This is applying the law, which says y raised to the power 4 times 5. Give us y raised to the power 20. Another one, 5 raised to the power 2, all raised to the power 3 is what? 5 raised to the power 2 times 3, which is 5 raised to the power 6. Given this kind of expression, here you will discover that this is having a coefficient before the base. In this case, once this coefficient is in the bracket with the index, you are going to apply this to the coefficient, then also apply it to the indices. So in this case, we will be having 4 raised to the power of 3, then y squared raised to the power of 3. Those previous ones, you assume that their coefficients are 1. So that is why it is not applicable. But in a case where the coefficient is greater than 1, you apply this power to the coefficient separately, then to the index separately. So in this case, we have 4 raised to the power of 3, which is what? 4 times 4 times 4 times y raised to the power of 2 times 3. So in this case, 4 times 4, 16 times 4, 64. We have 64 times y raised to the power 2 times 3, 6, which is 64 y raised to the power of 6 for this, because it has coefficient that is greater than 1. Please note the following. A, B, all raised to the power of x is the same as saying a raised to the power of x times b raised to the power of x, which is a raised to the power of x, bx. Also, a over b, all raised to the power of x, is the same thing as a raised to the power of x over b raised to the power of x. A plus b raised to the power of x is not a raised to the power of x plus b raised to the power of x. This is not this. And this a minus b raised to the power of x is also not a raised to the power of x minus b raised to the power of x. Power of 0. This rule tells us that anything raised to the power of 0 is 1. Power raised to power 0 is 1. A raised to power 0 is also 1. Let's prove it. If we'll be getting a 0 here, that means the number we have to subtract itself. In this case, a raised to the power of 4 divided by a raised to the power of 4. Applying the division law, a raised to the power of minus 4, which will give us a raised to the power of 0. I want us to prove how this becomes this and how a raised to the power of 0 becomes 1. A raised to the power of 4 dividing a raised to the power of 4 will give us a in 4 places over a in 4 places. A we cancel a we cancel a to give us 1, a we cancel a we cancel a. We are left with 1 over 1 to give us 1. The fifth law is the negative index. From this, it's stating that what if the power is negative? A situation whereby you have a raised to the power of minus x. This is a negative index. This is telling us that 1 over a raised to the power x. This is what the law is driving at. That once we have a negative index that is minus x, so it is saying that 1 all over a raised to the power of x. Let's prove this law. A raised to the power of 3 divided by a raised to the power of 5. If you look at this, ordinarily, it is going to give us a raised to the power of 3 minus 5, applying the division law to give us a raised to the power minus 2. Now, I want to prove how this a raised to the power minus 2 is going to give us 1 over a raised to the power 2. A raised to the power 3 is a in 3 places divided by a raised to the power 5, a in 5 places. A we cancel a we cancel a we cancel a. We are left with 1 over a in 2 places. So this solution is the same thing as this solution. Hence, a raised to the power minus 2 is the same thing as 1 over a squared. Having 2 raised to the power of minus 3, for example, how do we solve this? Applying the law is saying a raised to the power minus x equals to 1 over a raised to the power x. That is what the law is telling us. So if you have an expression in this format saying the base raised to the power of a negative, then it becomes what? 1. The minus becomes the 1 over 2 raised to the power of 3. So that is negative index. So to give us 1 over 2 times 2 times 2. To give us 1 over 2 times 2, 4 times 2, 8. So 2 raised to the power of minus 3 is the same thing as 1 over 8. Another example, 10a raised to the power of minus 3. In this case, the whole of this, we have a coefficient and the base, the whole of it raised to the power of minus 3. Applying the law, it is just saying 1 all over 10a raised to the power of 3. This is the coefficient and the base, the whole of it is raised to the power of minus 3. So this is how you write it out. So in this case, we have 1 over 10 raised to the power 3, a raised to the power 3. This is applying the bracket index. So here, what you do to the coefficient, you do to the base. So in this form, you now have it this way to give us 1 over 10 times 10 times 10 a raised to power 3. It was 1 over 10 times 10 100 1000 a raised to power 3. Fractional index is when the power is fraction. The denominator of the fraction becomes the root of the base raised to the power of the numerator. If you have, for example, a raised to the power of 2 over 3, in this case, the denominator of the fraction becomes the root. That is 3 becomes, the denominator becomes the root of the base, all raised to the power of the numerator. 9 raised to the power of half. In this case, applying the fractional law directly, this is square root of 9 multiplied by 1. So the square root of 9 is 3 raised by 1, which is 3. So now we want to prove why this becomes this. Looking at this, we all know that 9 is the same thing as 3 times 3 raised to the power of half. 3 times 3 is the same thing as saying 3 raised to the power 2 half. So in this case, we are going to apply the bracket with index to give us 3 raised to the power of 2 times half. So this is the same as 3, 2 over 1 times 1 over 2. So we cancel 2 to give us 3 raised to the power 1. Okay. Let us look at another example. 8 raised to the power of 2 over 3. The fractional index law states that the denominator becomes the root of the base, all raised to the power of the numerator. So in this case, 8 is just like saying 2 raised to the power of 3. That is 8. So the cube root. So the cube root will cancel the cube to give us 2. So the cube root of 8 is 2, all raised to the power 2 to give us 4. 2 times 2, 4. So 8 raised to the power of 2 over 3 is 4. Let us look at this question. Here we are asked to simplify 27 raised to the power of 2 over 3 times 3 raised to the power minus 2 times 2 raised to the power 3, all divided by 2 raised to the power minus 2. We can use various methods to solve, but here I'll be applying the fractional index. The fractional index states that you find the root of the denominator of the fraction and you raise the power by the numerator. In this case now, because it is fraction, you'll be finding the cube root of 27 all raised to the power of 2. Here we have applied fractional index multiplied by 3 raised to the power of minus 2 multiplied by 2 raised to the power of 3, all divided by 2 raised to the power minus 2. In this case now, the cube root of 27 is 3. That is 3 times 3 times 3 gives 27. So the cube root of 27 is 3. 3 raised to the power of 2 times 3 minus 2 times 2 raised to the power of 3 divided by 2 minus 2. Remember, this is in a bracket. Here becomes 3 raised to the power of 2. Remember, multiplication, applying multiplication law. 3 raised to the power of 2, 3 raised to the power minus 2, both are having the same basis. So here, 2 plus minus 2. We have applied multiplication here. Multiplied by 2 raised to the power of 3. Remember, 3 and 2, they are not of the same basis. So we will not apply any law here. So this all divided by 2 raised to the power of minus 2. Now 3, 2 plus times minus is minus 2 times 2 raised to the power of 3, everything in brackets, divided by 2 raised to the power of minus 2. 3 raised to the power of 2 minus 2 is 0 times 2 raised to the power of 3, everything divided by 2 raised to the power of minus 2. Now 3 raised to the power of 0, anything raised to the power of 0 is 1. So 1 times 2 raised to the power of 3, all in brackets, divided by 2 raised to the power of minus 2. 1 times 2 raised to the power of 3 is 2 raised to the power of 3, divided by 2 raised to the power of minus 2. In this case, you discover that 2 is the base. Both are having the same basis. So this, we can apply the division law. That states that division becomes a negative. So 2 raised to the power of 3, division becomes minus 2. So this becomes 2, 3, 2 raised to the power of 3, minus times minus plus 2, to give us 2 raised to the power of 5. So 2 raised to the power of 5 is what? 32. That is 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So this is our final answer. Alternatively, we can solve this 27 raised to the power of 2 over 3 using brackets with index. In this case, 27 is the same thing as 3 raised to the power of 3. That is 3 in 3 places will give you 27. Raised to the power of 2 over 3 times 3 raised to the power of minus 2 times 2 raised to the power of 3. All in brackets divided by 2 raised to the power of minus 2. In this case, if you apply the bracket with index, this becomes 3 raised to the power of 3 times 2 over 3 times 3 raised to the power of minus 2 times 2 raised to the power of 3, all in brackets, divided by 2 raised to the power of minus 2. 3 times 2 over 3 is 2. With 3, we cancel out the 3 to give us 3 raised to the power of 2 times, remember the negative index. If you have a negative index, it becomes 1 all over the base raised to the power. So 3 raised to the power minus 2 is the same thing as 1 over 3 raised to the power 2 times 2 raised to the power 3, all in brackets, divided by, here becomes the same thing as this. This is a negative index, 1 all over 2 raised to the power of 2. So in this case, 3 raised to the power of 2 is the same thing as 3 over 1. So this, we cancel out this. We are left with 1 times 1 times 2 raised to the power of 3 is 8. That is 2 in 3 places. 2 times 2 times 2, which is 8, all in brackets, divided by 1 all over 2 raised to the power 2, 4. 1 times 1 times 8 gives us 8, divided by 1 over 4, to give us 8 times 4 over 1, which is 82. So whichever method you find easier, you work with.